Speaking of a chance for a break in the clouds, let's go to Cleveland now, because by the time totality hits there around 3:13 Eastern time, to be specific, our Dave Malkoff may be able to see that total solar eclipse. Dave, good morning to you. This is fun for everybody, but scientists in particular, I understand, are also planning a bit of an experiment there. What do you know?
Good morning, Tony. This isn't just a place where you can get a funnel cake and look at the sky. This is what amounts to a huge NASA-sanctioned science experiment right in the heart of Cleveland. I grew up here in what is now called the NASA Glenn Research Center and the Visitor Center. It is now over here. The Visitor Center has moved to the Science Center, and over the weekend, we have all these tents that have come out. It is now a big solar festival with all sorts of experiments out here. NASA is launching high-altitude aircraft with better camera than they had back in 2017. They're also launching 3 rockets up into the ionosphere so they can see the corona of the sun as the moon crosses over and blocks it out. And that is what we hope to see right here for almost 4 minutes right here in Cleveland, Tony.
Very cool, Dave. Thank you very much.
You should get out. And you know what? I'm going to help you out by taking us to our next correspondent, Dave Malkoff. He's out in Cleveland, Ohio. So, Dave, I want to hear from you how the experience there compares to the experience here. How's the cloud cover? How does everything look for you?
Lana, it really feels like it's a party over there in Indianapolis, and it feels like an even bigger party here in Cleveland. You asked about the cloud cover. I looked over Lake Erie. I only see one wispy cloud right now. We are hoping and praying that that actually stays that way. This will be not only just a big party for the people in Cleveland, but also a science experiment for NASA all over the country, and they'll be able to not only fly high-altitude aircraft, but in Virginia, they're launching 3 rockets into the atmosphere to test what happens when the moon eclipses the sun and you just see the corona. That will be so cool to see right here.
Absolutely. You know, here we also have Purdue scientists and NASA scientists. There's a School of the Blind that is launching balloons into the atmosphere to study it. There's so much science. There's so much excitement. And I know, Dave, that even though for me this is the first time I'm experiencing totality, you covered it back in 2017. In what ways is this different?
So we're calling this Total Eclipse of the Heartland, right? That's an obvious reference to Total Eclipse of the Heart. It is the #1 single from Bonnie Tyler. Look at this. Look where I was in 2017. So the eclipse path went from Oregon down to South Carolina, then popped off the coast. You would think nobody can see it after it goes into the ocean. No, we got on a cruise ship with Bonnie Tyler and Joe Jonas, by the way, and actually took that cruise ship and pointed it right into the path of totality. So as we were looking at the eclipse above us, Bonnie Tyler was singing Total Eclipse of the Heart to us. So that may be the top eclipse moment, but can you imagine what it's like to look into? I'm so excited for you, because you'll be able to look into the universe the way it actually is and see the corona and be able to see that with your own eyes. Up until that moment, you'll have to have the glasses on. But when the corona pops out, you can actually safely take off your glasses and look at it and marvel at the outer atmosphere of the sun. I know you love this stuff.
Yes. And we're expecting a lot of solar activity, actually, so we may have a particularly beautiful corona, I understand. But a good point, if you are not in the path of totality, do not take off those glasses no matter what. I'm going to send it back to our friend Lilia, who's in New York City, and unfortunately, she's going to keep on those glasses the whole time. Lils?
I made sure that somebody brought me a pair because I thought I wasn't going to be able to see it. Now I've heard that I will be. Lana, thank you so much.
All right.
Millions of Americans are just minutes away from the start of something we're not going to see again for the next 20 years, a total eclipse of the sun. The Earth, Sun, and Moon are all about to align in such a way that the Moon will completely block the Sun. More than 31 million people in a line from Texas to Western New York are all in what's called the path of totality. These folks will be treated to the most dramatic swing from light to dark over a period of a few hours. So let's head over to Cleveland, where CBS News national correspondent Dave Malkoff is joining us. Dave, so great to see you. So remind us, why is it so important to look at the eclipse only through those special glasses, and hopefully not the rip-off kind, the real ones?
Yes, yeah, I've got him right here. Oh, Liliana, that is a great question, because you think of anything else in life where 99.9% of it is basically the same thing as 100%. Eclipses are so much different. Even 99% of an eclipse is still staring into the sun because a little sliver of the actual sun is still coming through. So you still need to wear your glasses that will black out everything except for the sun coming through. But once the moon moves directly over the disk of the sun, you can actually take your glasses off at that moment where right after you see the diamond ring effect, you'll see a flash, and then everybody can take off their glasses. What you're staring at is not the solar disk of the sun, but the atmosphere of the sun. You're looking at the corona, all of that gas and plasma coming off of the top of the sun. And it's an amazing thing because you never see that because the sun is just so bright. So that is the reason, Liliana, why you need to keep on these glasses. It's pretty bright out here, so maybe I'll just keep these on for the rest of the live shot.
They don't look bad. They don't look bad. So, okay. So when we think about what we will tell our children that we got to see, what do you foresee is the most exciting part of this? Why should people, care and get excited and look up with the glasses?
That's a great question because there's two reasons I can think of. Number one, we spend so much time looking down at our phones and
I think we lost him, but I'm sure he was saying that, look up with the glasses. It seems like this is the kind of moment where you can let someone else take the photo. You can just be in the moment.
Well, thousands of people have converged on downtown Cleveland for the eclipse, and they are about to experience what we just experienced here, totality. And CBS's Dave Malkoff is there. Hi there, Dave.
Dave, you're in for a treat.
I know. Yeah, I can't imagine what you guys just went through. We are with Captain Steve Bowen. He has been to space 4 times, 3 times on the shuttle, 1 time on Dragon, and he is experiencing this. Here it comes.
Here it comes.
Steve, tell me what you're seeing right now.
It's shrinking, and we are almost there. It's getting smaller and smaller. It's
This
just
is
a little
incredible.
tiny sliver. There it is. You're starting to see the little glimpse. And there we are.
This is the very edge of it.
This is
We're
it.
seeing the
There you
sparkles
go. You can actually see
over the edge.
There it is.
of the sun.
Look at the ring. Look at the ring. There you go.
Oh, wow. Captain Bowen,
Incredible.
that's incredible.
Isn't that amazing? Unbelievable. Look at that.
When you sit there in the cupola and you look down at Earth and you realize how fragile the whole place is, that is a moment that
That's it.
you have that no one else gets to experience. We get to experience that now.
That is amazing. It is absolutely unbelievable. There's nothing like it. It is. Look at this. Look at the darkness.
Is this
This
a
is
bit
incredible.
of what you get in
Oh,
the cupola?
absolutely. This is just incredible. Look around. It is unbelievable.
It's nighttime here.
It is. Look at
We're
that.
looking at the edge of the corona. These prominences that are coming off, you almost have to worry about the solar
space
wind
weather. That
is
is
coming
space weather.
towards you
Yeah.
because you're unprotected.
Right. So
except
what
for
you're
the-
seeing there is it's obviously going out from the sides of the sun, but there's, sun's a sphere, so it can come towards you as well. But it gives everybody a sense of what you're seeing. And if you look, you see that lower corner there, there's obviously an ejection that's pretty brighter than everywhere else.
Yeah.
And that's what space weather is when the sun ejects mass and energy from the sun itself. And that's what that little bright spot is. Isn't that incredible? That's a
And
massive...
the one thing that can protect you is a bubble of water sometimes around
Yeah, bubble
you.
water will, and the Earth's magnetic field is the biggest thing.
But when you're in space.
Yeah, we have the Earth's magnetic field where the space station is. We're only 240 miles high. But when we go to the moon, we'll be moving outside that area of protection. And that's something really important that we have to take into account as we go further and explore deeper into space. But that's incredible. Look at that. It is absolutely amazing.
These prominences that are coming off of here, they look like wispy edges, but those are way bigger than the Earth is.
Oh my goodness, yeah. the sun is gigantic. That's something to keep in mind. And there's a lot of good NASA websites that will explain the sun's science, Helios, and they actually have space weather predictions. So we can see this. It doesn't get here. It doesn't travel at the speed of light. What we're seeing, that happened 8 minutes.
8 minutes ago. That's eight minutes away.
Right. So that's with the sun. Obviously, the moon is not that far away.
Yeah.
But that's traveling at the speed of light. The actual energy is traveling a little bit slower, so we can actually forecast what that impact is going to be on Earth.
The moon is not a pool cue. It's not. It's actually got bumps on it.
It does.
So when the sunlight goes around it, we're going to actually see what?
Well, so we'll see little tiny, as it comes back out, you'll see the little prominences, like sort of a bubble.
Well, we got to head back, but thanks you so much for joining us.